Everyone, this is Shinde Geeta. I'm here to explain about case study on topic real-time application of open loop and closed loop system. Guide by Dr. UV Patel sir. Came to the point of elaboration. What is open loop system? A control system which doesn't have any feedback connected to it is called open loop system. This type of system don't depends upon its output. Is that in the open loop system output is not used as a control variable for the system and it has no effect on the input. The given below block diagram shows us about open loop system explanation. Come to the example point of view. Real time example of open loop system is electrical clothes dryer. Basically, day by day, we all use this. We operate the clothes dryer depending upon the amount of clothes to make dry. We set a timer in the system to do this operation. Let's say 20 minutes as it is an automation of open loop system. The machine stops working automatically after 20 minutes, irrespective of the nature of the clothes, whether they are dry or damp. The clothes dryer in an open loop system because it doesn't consider the condition of clothes before it stops working. The user can adjust the operating duration of the system by setting the timer control as per his or her requirement. Observe the below block diagram for the open loop system. Electrical diagram explain about the example. Here the electrical dial system has three blocks: timer, heating elements and clothes. Previously, the user sets the time for drying the clothes in the timer, and the timer control work in the combination with the heating element to produce heat and dry the clothes. As there is no feedback about the clothes humidity, the system stops working about the present time, and it doesn't consider the state of clothes even if the clothes are dry. The system will switch off after the allotted time. As the system has no feedback, this is also known as non-feedback system, in which the output of the system depends only on the input signal and no control action of the input signal based on the output is provided. Over to you, Tejashri.
Thanks, Geeta. Hello everyone, I am Tejashri Thete. Today I am telling you some example of open loop system. First is electric cloth dryer. This system may be affected by large deviation in output when the present value of the system drops away. As the open loop system doesn't have any knowledge of the output, it cannot correct error itself. This is a major disadvantage of the open loop control system. Another disadvantage is that this system cannot handle the external disturbance and have very poor ability to oppose the adoption of changes to external system parameter. This is the block diagram of electric clothes dryer. So we came across a discussion that the error occurred in open loop system will disrupt the drying process and to maintain stability. This system requires the regular attention of user. This means the user need to check the process and the temperature of clothes frequently and take control of this machine when it deviates from the requirement conditional circumstance. Another example is word processor. This is also an open loop control system. When information is entered through a keypad, then other blocks like hardware components in the control system will process the information and display it on LCD. When typing the peripheral is stopped by the operator, then no input is given to the system, so nothing will be displayed on LED. So word processor become an example of this control system. Another example is electric hand dryer. The hand dryer works on the electric power supply. When the hand is kept in front of it, hot air will be blown from it for some time for making the hand dry. It will not consider how much of a hand is dry. It will only consider the time. Thank you. I'm over to you, Samruddhi.
Thank you, Tejasri, for explaining the previous slides. Now, Samruddhi Anil Vadgaonkar here. I am going to tell you about closed loop system. What is a closed loop control system? A closed loop control system is that where all devices or components work automatically and regulate a process continuously without any human interaction. It means it is a completely automatic process. There is no need of any human interaction. A closed loop control system is also known as a feedback control system because Here is a feedback signal from the output, always controls the input. You can see here a one block diagram. Now we can see the real-time examples of closed loop system. One of them is voltage stabilizer. Voltage stabilizer is an example of closed loop control system. Here you can see the block diagram of the voltage stabilizer. You can see here a feedback control system is available. It continuously monitors the output voltage. So, when the output voltage increases or decreases from a certain level, the feedback system sends a signal to the input circuit. So, it can increases or decreases the voltage level to maintain a constant output voltage level. Another example is temperature control system. It will explain from the Tanuja Pagar. Thank you.
Thank you Samruddhi for explaining previous slide. Now Tanuja Pagar here. I am going to tell you another example of temperature control system that functions as a closed loop system. The main purpose possessed by a temperature control system is to maintain a constant temperature of water. Generally, these systems are used to provide an invariable temperature, that means hot, at the output. The figure below represented the block diagram representation of closed loop system. Basically, in such type of systems, water from an outlet comes with a constant flow rate. Also, internally generated steam for a valve is mixed with the water to have a predetermined temperature of water. A pressure thermometer is used inside the system that acts as a feedback. So, when a reference input is provided to the system, then the valve present generates a control signal that indicates the system to provide the required amount of steam. When the steam mixes with the water coming from the outlet, then the temperature of the water is mixture by the pressure thermometer and is compared with the reference input given to the system. If the desired temperature reference input shows equivalence with the generated temperature, then the control signal is generated and the flow of steam is stopped. But if some amount of variation exists between the two temperature valves, then the controller generates the control signal regarding the level of temperature difference, which is further compensated during the process. In this way, the continuous process inside the system takes place and a control level of a temperature is maintained. Thank you.